Morning, everyone. Welcome. Yeah, thanks for coming in early. It gave me the great opportunity to talk to some of you folks in person, kind of figure out why you're here, what you do. My name is Dandy. I'm the only Dandy at Microsoft, and I'm the technical product manager on Parallel Data Warehouse. With me, I have Brian Mitchell. He's a premier field engineer, and he's been working closely with a lot of the PDW appliance infrastructure, customer deployments, and such. Both of us are certified masters on SQL Server, so if you have any questions afterwards, SQL related, come and find us at the booth whatsoever. I hope you have a good session, and let's have a look on data warehousing and how nowadays data warehouses look like. If I think about data warehouses, what I see a lot is that people's data warehouses kind of look like this, right? I mean, how many of you folks have a data warehouse, and what's wrong with this picture? There's a couple of things wrong with this picture. If you look at it, are you going to be able to retrieve the data that you need to recover? Absolutely yes. There's no doubt about that, okay? But looking into the details of these pictures, you'll see that it's unstructured, it's definitely unbalanced if you look at some of those, and it's unpredictable what your result set will be. And that's exactly what you have in nowadays data warehouse deployments. What a lot of people actually do is they have this giant big SAN, they put everything on the SAN, and they add a little server to it to connect to the SAN, and then when they need to grow or scale, they're going to add servers to it, and they're going to add networking to it. Sounds familiar, right? So we'll add a server, we'll add another one, and that's supposedly to be my data warehouse. And if I'm fortunate and I don't have any budget constraints, what probably happens is I could have this dedicated to my data warehouse, but a lot of times you see that you're going to use your SAN storage for the file system, OLTP, which are definitely different workloads. What's the problem with it is you might have and run into some potential performance bottlenecks. It could be that you have a storage controller that supports much more bandwidth than your actual disk capacity or disk transfer supports. Or you might run into switch issues or even SQL Server read-ahead caching that might cause all these conflicts. What if you don't have enough workload to handle the CPU workload you have and you don't have enough CPU cores aligned, or you don't have the right architecture or tuning and optimization in place? Okay? So that's key when you build out a good data warehousing solution. And in general, it's all about sizing and some alignment. If you look at this semi, right? There definitely needs to be some alignment in order to make sure that you have the right size and you could fit. The right tool for the right job is very important. So you'll see that when we look at data warehousing, one shoe does not fit all. There's different kind of workloads. And if you look at those workloads, we have transactional processing, we have data warehousing, and we have what we call business insights, translating into analysis that you're going to do on that data. Very different, distinct workloads. Transactional processing is going to drive your transactional, and your data warehouse should be your stored information, enable you to generate a data model that allows you to do your data analysis and provide your business insights. Now, when we look at the data warehouse scope by itself, we'll see that we have the presentation layer. And I assume you've been to the foundational session, you've been to some of the other presentations that run on the DBI track focusing on business intelligence. So you're already familiar with what we do with Power Pivot, Excel services, publication into SharePoint, the presentation layer, and some web analytics tool or reporting services that you use, or even to that point, you probably are looking already at Project Crescent, allowing you to retrieve data from your data warehouse, whether it's sitting in a private cloud or whether it's sitting public. If you look on how you're going to leverage and provide that data, you probably look into building out an analysis services cube, but the key central focus of your data warehouse should be your dedicated SAN, your storage array, your data warehousing, where you're going to focus on how you're going to stage and load the data, and how you're going to bulk load and then retrieve that data. And that's what we'll be looking at in this session. Now, what I said, one size, one shoe does not fit all. Looking at the data warehousing scenarios, you'll see that data warehousing in general is used in large enterprises. And that's where we come in as Microsoft saying, well, we want to extend that functionality and provide that data warehouse at any level, any scale, optimized for every workload. You don't want to walk around in a shoe size 14 if you need a 7, right? So the self-servicing BI tools, such as Power Pivot reporting services and such, have created this data warehousing requirement that needs to be adoptable for any customer, any kind of platform. And that's what we have to offer with our Microsoft data warehousing offerings. Now, what we'll be looking at is the traditional one. We have SQL Server Enterprise. It's SMP architecture, ideal for small data marts, mid-size, enterprise data warehousing. It's a software only, and it's a scale-up data warehousing solution that we target to be tens of terabytes. You could go, let's say, 40 terabyte. Well, yeah, you could use SQL Server Enterprise and do everything yourself. Now, I asked around a bit, and I have DBAs in the room, right? How many system engineers are in the room? Okay. Those system engineers would probably focus much more on the storage capacity, the Windows Server platform, how to tweak the operating system, while the DBA will care about how am I going to tune SQL Server in order to get a good optimal solution. Now, looking at the solutions that we provide, we have an appliance-based architecture, and we have a reference architecture that we call Fast Track Data Warehouse. Everything that we're going to show here is the BDW appliance, the Fast Track Data Warehouse reference architecture, and the MPP architecture, parallel data warehouse, will focus on those key aspects, designed, dedicated to a data warehousing workload. Fast Track Data Warehouse reference architecture will allow you to scale up from 5 to 80 terabytes, and then we'll translate or transfer that into the massive parallel processing architecture using parallel data warehouse. So putting those offerings together and looking at the effort to build it, if you want to deploy a solution based on SQL Server Enterprise, there's quite some effort to build, streamline, optimize. You have to purchase the hardware. You're going to do the research yourself around it. Looking at the other solutions, the Business Data Warehouse appliance, very low effort to build. It ships out of the box, and actually you will be up and running with that appliance in less than 20 minutes. Okay? Fast Track Data Warehouse, slightly moderate to build it out, different architectures with your choice of hardware vendor and so on. Very easy to build out, different capacity, concurrency that allows you to do light, medium, or very high performance loads, and then the query complexity that is designed for massive parallel processing will then translate into our BDW solution. Now, the BDW appliance, low entry, complete solution, hardware, software, services, pre-tuned, pre-configured, actually based on our Fast Track reference architecture. Okay? Deploy in hours. Of course, if you're going to design your data model and you're going to deploy that, it's going to take you a couple of days, not in months. Now, fully Fast Track compliant, which means that we already optimized everything. How does it work? Small scenarios. It could be a spoke in a distributed architecture. So you could have a PDW appliance being your core enterprise data warehouse and then integrate with our Fast Track reference architecture or integrate with a small BDW appliance, allowing you to build out an entire distributed hub and spoke architecture. What's in the box? Server, HP ProLiant, Westmead processors, so you got 12 cores, 96 gigs of RAM. There's internal storage based on Windows Server 2008 R2 Enterprise and SQL Server 2008 Enterprise. Now, what is key about this is you order this as a single SKU, and everything is optimized. Your data load, your data process, you name the appliance, join the domain, specify who's the admin, so fully integrated wizard that's going to take care of your configuration. ETL processes using SQL Server integration services, automatically allowing you to transfer that kind of data. The reference architectures by itself, how many of you actually implemented the Fast Track architecture already? No one? How many of you are aware of the fast track reference architectures? Okay, perfect. We have about 20 people. And thank you, Brian, for being aware of it as well. How does it work? We provide you with all the configuration guidelines. How should your physical table structure look like? How should you build your indexes optimized for a data warehouse? What do you do with enabling compression? Where do you put your file groups? How many file groups do you need? What specific SQL Server settings do you need to have in place optimized for data warehousing? Going into trace flags, setting your query parallelism. What about the Windows Server settings? You're not going to optimize that for desktop experience, for example. And we provide you with guidance on how to load the data. Those reference architectures are actually published and specific with different hardware vendors with very tight specifications on that server, storage, network alignment, and you can do a per core building block allowing you to select what is the number of cores that I need, what is the workload that I need in order to accomplish this. So looking at a solution example, you could have a server with 2 6-core Intel Xeon processors. You have 4 proc configurations and 8 proc configurations. It's a reference architecture in which we specify what your storage server is going to be, how you need to put in the network cabling and the switches, and how you need to wire everything up, and then how SQL Server is optimized or needs to be optimized for you. Okay? And then you deploy that. We work with several partners on that, as well on the hardware side as on the software integration side, but your solution to deployment is actually going pretty fast. Now, the BDW appliance and the fast track reference architecture are SMP architecture, so we're not using any massive parallel processing there. One of the key questions that you need to ask yourself is whether you need that query workload or not. For the majority of data warehouses, you probably could implement the fast track reference architecture, or you could implement the BDW appliance. Right? Looking at sizes, there's very few sizes that go into the hundreds of terabytes or the 500 terabyte range whatsoever. Now, PDW, our tier 1 enterprise data warehouse solution, offers you scalability up to hundreds of terabytes. What you showed yesterday and what you looked at yesterday in the foundational session was querying of rows that have billions of records with a join that goes over those multiple records. We offer you flexibility of choice in terms of deployment options with a distributed architecture. So you could say everything rolls up into my enterprise data warehouse no matter what my data source is. Right? If you're sitting in an Oracle environment, OLTP, and you want to stage that into a BI-based Microsoft solution because you look at the advantages of reporting services and so on, you can move that data, load it into a distributed architecture where PDW would be the ideal candidate to get that mass storage with billions of records sitting into one table or being built out on that reference architecture. Now, what are the details? PDW, by default, when we talk about a PDW appliance rack, we have a rack-based solution that consists of what we call a control rack and a data rack. And that data rack, at this point, you could extend it up to 4 data racks, giving you up to 40 compute nodes. Now, how does massive parallel processing work? The concepts behind it sit into the high-performance computing space, where you're going to combine all those nodes together and have them working simultaneously in an ultra-shared nothing architecture, where you have the opportunity to do distributed tables, or you could do replicated tables. You could say my most frequently queried table is going to be sitting on any of those compute nodes. Think about the I/O performance you get there and the number of disk spindles associated with that. All of it with built-in high availability. Now, we got some DBAs in the room, and as a DBA, one of the first questions I will have is, what if I have 40 compute nodes, and each of those 40 compute nodes have SQL Server installed? How am I going to manage and patch and maintain all of that, take backups? You don't. You're only going to manage it as a one single server solution. So looking into the details of that control rack and data rack, you see that a control rack has a set of servers focusing on management, focusing on patching, focusing on backup, and focusing on optimizing your data load and ETL process. The data rack, with storage directly attached to your compute nodes, will take care of your data. You're not going to manage those as individual servers. Okay? What Brian will show you in the demo is you're actually going to manage that to the single control and management console. So the control rack is where all client queries will go to. It will process your SQL Server requests. Now, we have some very experienced DBAs in the room, and what you probably already deployed previously on SQL Server is an architecture where you work with distributed partition views or whatsoever. The key challenge there is you're actually not executing all that compute nodes together. You don't have the high availability. You don't have the scale than what we have with PDW. So the secret sauce of PDW, as we call it, is sitting in that control rack. It's taking care of your query processing. It's taking care of your table creations. When you design a distributed table, you're going to have one create table command. Not many on different servers, because that's what PDW does. That's what will be taken care of. It will take care of the execution plan, orchestrate the distributed architecture, and retrieve your query. And you have connectivity into it directly to the control node. So as a single unit, the end user will see PDW as one SQL server. The DBA will see SQL Server Parallel Data Warehouse as a single server. You're not going to touch any of those individual nodes. Now, when it comes down to management and patching, the management and patching is provided by the management node. Okay? Management node internally provides the support and the patching for the entire appliance. So when you apply a service pack or an update to PDW, that's been taken care of by the management node and then individually managed on each of those control nodes. Now, in order to manage that, PDW uses an internal, well-tested, well-driven Microsoft architecture. It uses Active Directory internally to do the patching, to do the updates, to provide the high availability management, clustering, and so on. Okay? So you're not going to touch that. It's taking care of the management node. It's an internal, private Active Directory domain used by PDW internally, to give you some insights into that. ETL processes. Many times we see customers that want to load their data warehouse over a slow network. What is your optimal load on a single SQL server if you want to load data? You got a couple of capabilities there, right? Some of you might have worked with SQL Server integration services or previously with DTS, and point that to a data source that is sitting somewhere on the network, and you see all that data flowing over the network. Others might have chosen on SQL Server for an architecture where you actually put everything into load files, you pre-stage them on a server, and you load them from that server into your data warehouse that is well connected to the data warehouse. So you put a server or a staging database close to it. And that's what we do within the control rack, is what we call a landing zone. It's a high-capacity storage for data files or ETL processes. The landing zone provides SQL Server integration services. So you could run integration services on that landing zone, putting a set of data files locally and then load it into PDW. Now, is that optimized for bulk load of data that has already been cleansed using data quality services, for example? Not ideal, right? Because if you look at SQL Server by itself, the fastest way to load data is to bulk insert that data using BCP on a standard SQL. In order to provide that capability on PDW, we have a dedicated load process on PDW that is called DW Loader. So that's the load process that you're going to use to go from your source. So you get to your data source, you go to the landing zone files, and then you use the data loader process, which could be DW Loader or SQL Server integration services. If you're not making any transformations at that point, you're loading into a data warehouse. DW Loader is going to provide you the most performant extreme data load possible. How is it going to work? Again, you load it as you're loading it onto a single SQL server, and based on your table architecture that is defined, it's then going to break that down over those compute nodes. So the distribution architecture, the replicated table model, which is a very unique model that we have with PDW, is automatically going to be managed from that landing zone directly onto each of those compute nodes. Perfect. Now, how do you backup, right? What's your backup solution with PDW? With the appliance, we provide you backup capabilities that, again, are directly attached onto the appliance. Why? You want to minimize network traffic. You want to minimize data transfer. And you want to optimize your backup solution as well. So we have an integrated backup solution from within the SQL Server Parallel Data Warehouse Management Console, where you could go look at your latest backup, perform your backup, and it's going to take care of that backup over those control nodes and actually back up your data the way it should be. You could order that, and that's like the only configuration option you have with PDW, is you could specify, oh, my appliance, I need this level of capacity in terms of backup. Okay? And then you could integrate that with an existing third-party backup solution that you might have. What are you going to keep current on that backup node? Probably the most recent data, right? The historical 5-year-old data is probably going to sit on your corporate backup solution that you already might have in place, or an additional storage that you did attach to provide that functionality. Looking at the data rack consists of each of those compute nodes, and each of those have SQL Server installed. They're all instances of SQL Server that as a DBA you're not going to touch. Why? Because they're managed by the management node, and your only entry is the control node. Looking at the data rack, we have 10 in a one rack PDW. We have 10 active and 1 passive, what we call compute node. Compute node consists of a well-connected InfiniBand. We have Ethernet switching. It's a 42-unit rack. And you could grow and expand that from 1 data rack to up to 4 data racks, giving you storage capacity that goes well beyond 500 terabytes of data. Okay? And if that doesn't work, put another PDW in place and put them into a distributed data warehouse architecture. So the data rack consists of your compute node and your actual storage nodes. Now, what is that passive one doing? The passive one is sitting there in case of you have an entire compute node failing. Okay? Your storage is redundant, but let's say you have an entire compute node failing. What you can do then is through the management node, you could redeploy a compute node and re-image an entire compute node. But that's where that spare passive node will take over the management of any of the storage that would assign with one of the failing nodes there. Okay? Looking at the compute node, which is part of your massive parallel processing architecture, it's an SMP node, standard interfaces, dedicated hardware, dedicated storage. They all run SQL servers. They all have their local TempDB, and they're configured as a RAID 1 configuration. So what happens there is, yes, you're going to leverage TempDB at some points in terms of your query processing as part of that query that you perform over each of those compute nodes individually. Management, again, done through the management console. Now, if you look on PDW connectivity, you see that yellow line there, like right in the middle. You have your client drivers, you have your support and patching, ETL process, and corporate backup solution. Okay? Everything on the right side of that line is the PDW private network. Okay? It's the control rack and the data rack, well connected, working together. So the client driver, the standard driver that you're going to see is we have a connector for SQL Server integration services. So we have a PDW input and output connector. And we have client connectivity that allows you to connect directly from, let's say, Power Pivot to PDW appliance. what you see happening is a lot of people will probably build out an analysis services cube on top of it, which might not be the right solution for your architecture. You could build out your report with a direct connection to PDW and do your query processing directly on the appliance. So you save time, you get much better query performance, and you get much faster results to that perspective. So what happens is when I formulate a query, that query will go to my control node and then will be handled by each of those individual compute nodes. Yeah, that's all good, Danny, but let's have a look at this and see this to action. And Brian is going to drive us around that and kind of lead us through the appliance, look at each of those nodes, the management, and those capabilities. All yours.
All right. Right before we start looking at those queries, one of the things that we want to talk about is administration of the appliance. So when you take a look at, you start thinking about 47 nodes in an appliance, if you're talking about a 4 data rack appliance, how are you going to manage that? And one of the things you want to do is be able to see it all in one window. So we use an IIS version to be able to take a look at a high level of what's going on in my appliance. And from an appliance state, I can take a look at the entire appliance and see whether I'm up, whether I'm down, and what kind of alerts I have. So not only can I see the control rack, but I can also see the compute rack, and I can see not only from a software level, but also at a hardware level, what's going on and what alerts I have. Because the last thing I want to do is have to go out to any individual node and look at the event logs to find out what's going on. So we can see our appliance here. We have lots of hardware alerts and software alerts that tell us, are we up, are we down? If I wanted to look just at the alerts within the appliance, I can come over here and I can see actually this appliance has a few alerts, mostly around storage because we have multiple databases on here. But I could dive into these as I wanted to. So from an administration standpoint, we have one view into the appliance to look at, and this is really important. For any one of these individual nodes, I can dive into them a little deeper, and I can get additional information if I needed to about storage, network, memory, what have you. So you're taking a look, you see at a high level what's going on. Also, from an administration standpoint, Dandy talked quite a bit about the management console or the management node and be able to go in and look at and administer the appliance from the management console. So let's take a look at what that looks like. And one of the things we have is a configuration manager on the management console, which allows us to do things such as stop and start all the services within the appliance from one node. So from here, I can look at the state of all the appliances or all the nodes within the appliance. And if I wanted to, I could stop all the services.
Please don't.
This is also where you can manage firewall, network configuration. Everything you need to manage or change within the appliance, you do from here. You don't go to the individual node. You go here and you make those changes here. Speaking of those nodes, he talked about these compute racks, and they're 10 plus 1. Really all they are, they're just failover clustering groups. So you can look here, we have the control rack, in which we have the control node, which is an active passive failover cluster. And then we have 4 other clusters within this particular appliance, which is a 4 data rack appliance. If I took a look at one of the compute racks, I can see I have 10 instances of SQL Server running on here. They're all running on their individual 1 through 10 nodes. And then if I look at the nodes, I also have my failover spare available for them if they fail over.
So question and comment there. Let's be clear about this. This is something that you're not going to configure or you're not going to touch, right? That's part of the appliance.
For you.
It's pre-configured.
It's just good to see that when we talk about all this, it's failover clustering. It's it's the same technology that you're used to and you're used to using. So going back up here, let's talk about what PDW is a little bit from a service, and then we'll get down into the actual creating of the tables. PDW, at the end of the day, is a service running on top of SQL Server. At the control node level, what we have is we have the PDW engine, which you can see right here, which is what actually takes your queries in on the control node and it parses your queries and creates a massively parallel plan for your query and parses it out and sends it to all the compute nodes in your data racks. What the PDW engine does is once it's parsed that query and it's created the query plan, it speaks to the data movement service on the control node, which then speaks to the data movement service on all the compute nodes within the appliance. And what the data movement service does is it speaks to SQL Server. It passes queries to SQL Server. It lets SQL Server just answer the queries and pass the answers back to the data movement service that passes it back to PDW and then back to the user. So it's just a service running on top of all of these SQL servers running on all your nodes. And we'll start taking a look at that. So let's start at the beginning. I now have a PDW appliance. First thing I want to do is I want to create a database, right? So creating a database has a couple options, and this is where we're going to start talking about the two different choices of creating tables in a data warehouse. You have choices of replicated tables and distributed tables. Replicated tables are tables that we're going to put on every compute node within the appliance, and so you want to think of them as your smaller dimension tables. What we're going to do is take a full copy of that table and place it on each compute node. And so for your smaller dimension tables, they don't take up much space, so it's not a big deal to place a copy of that on each compute node. And the reason why we're doing that is so that when we want to join it to your larger fact tables, we have a full copy of that distributed or that replicated table available on your compute node, available to answer the query wholly from any compute node within your appliance.
So I got a question on that, Brian. I'm a DBA, right? Mm-hmm. I look at this create database statement and I see it's fairly simple. I mean, you're not specifying any file groups, you're not specifying any data files, where you're going to put your data files. How is that managed?
That's a good question. So it's managed right with this with statement where I say replicated size and distributed size. Your file groups and your files have already been laid out for you. Your replicated tables have one file group on each compute node that spans all the LUNs within the compute node. So when I say replicated size equals 0.5 gigabytes, what I'm saying is I'm creating a replicated file group of a half a gig on each compute node within the appliance. Now your distributed tables are spun out so that you have 8 file groups per compute node, and we're going to create a distributed size of 5 gigabytes across the entire appliance, where we're going to take a portion of that and break it up into the smaller sizes on each distribution. So creating this database, what I'm doing is I'm just specifying replicated and distributed file groups, and it's going to create those on the file groups that are already created within your appliance. And this usually just takes a second or two.
So this is what we call a marketing slide, simplified data warehouse management, right?
Because if you think about it, in your large data warehouses, this is much more complicated. You're laying out file groups everywhere, and then you're going to create a database on those file groups. And then after it's done and you start running out of space, you have to start managing those file groups by creating more and moving data around. It's fairly typical. It's a very DBA intensive environment. Here, we just can expand these file groups until we run out of space. Now, let's go back to talking about a replicated table. In this case, I've created my database. Now I'm going to create a replicated table. I'm adding an additional statement down here that says create this table with replicate. So what this is doing is I'm creating this dim entity table on every single compute node. And if I load data, that data is going to exist on every single compute node within the appliance. That way, if I wanted to join it with any other table, I could do that. And what I'm doing here is I'm using this DMV. And this is where you can see that we have DMVs that you know, like sys.tables. We can join them to new DMVs that are available for parallel data warehouse, like PDW table mappings, to get some information out of the appliance. Like here, we can see that when we created this table, we created one physical table, and this physical table lives on each compute node.
So what basically happens there is initially I talked about doing a SQL Server distributed partition views where you would have to create tables on each of those instances. PDW, you have one single create table statement that's going to run on each of those compute nodes individually, create a table. And can we see those tables? Oh, yeah, we do. We got the physical name of it.
Right, we see the physical name down here.
So that all happens behind the scenes, and it totally aligns that in terms of the create table statement. Now, this is very unique to PDW, that replicated table model, because what you basically do there is you say, I have this table, and in my load process, that load is going to go to each of those compute nodes, and that's what we call ultra-shared nothing architecture. Because every query that will hit those distribution tables that will join with that replicator table will run on those compute nodes individually without impacting any query performance or impact on any of the other nodes that might not need that replicator table at that point because you're not hitting that distribution. Okay?
So now let's talk about something more complicated, which is your distributed tables. Think of your large fact tables. When you start talking fact tables of multi-terabytes in size, the way that we handle those is we break them down into portions. So in this particular appliance, we have 40 compute nodes. And what we're going to do is when we create this fact table, we're going to break this fact table down into, first, let's think 40 portions, but actually on each compute node, what we're going to do is we're going to break it down into 8 more portions. And each one of these portions is called a distribution. So in a 40 data rack appliance, we're going to have 320 distributions. What these distributions are, they're really individual physical tables. Each one of these individual physical tables lives on its own LUN with its own set of disks within the appliance. And so what we're doing is we're creating 300 physical tables, and what we need to, the way we do this is we have to decide on this table, how are we going to distribute this data? Because each row of data is only going to exist in one distribution out of those 320. And so we're breaking this large table up into much smaller pieces that are all going to live on their own LUNs and all on their own disks. And the way we do that is we pick a key, a distribution key, in which we hash this table on. So in this case, I'm picking a distribution key of inventory key, and I create this fact table. And what this does is go out and actually, well, logically it's one fact table from a PDW experience. At the physical level, it's 300 physical tables living on 300 separate LUNs with their own sets of disks. And that's where we get the real power of PDW, is being able to pull that data off of all these different sets of RAID 1 arrays within the appliance. So
We got a question in the back there.
So you don't have to make a decision up front as far as like petitioning on the side of phase or month. You just basically create the table and then behind the scenes, the warehouse appliance handles breaking up the structure on its own. So you're not really involved in it. It's other than choosing the best key.
the distribution key.
So let me repeat.
Sure.
Let me repeat the question. So the question is, you're not making any decision when it comes down to how you're going to distribute, create a table, set the partitions, and everything. Correct? That was your question, right? Yes. Yeah. Okay.
So in general, no. You pick the distribution key, and then PDW determines where that data goes. Now, you can, on top of distributing data, you can actually partition the data also on a different key if you need to. So for example, if you're loading by date, you may partition the data by date, and what you're actually doing is you have 320 tables in this particular appliance. You're actually partitioning all 320 of those physical tables on the back end by date now. You probably wouldn't do that for performance reasons, but you definitely may do it for loading reasons, right? So you may be loading a partition of data per day by date, and you could swap in the oldest date, bring in the newest date, and you would do that. That's actually done on all the tables. But from a distribution standpoint, all you do is pick your distribution key, and that hash will determine where the data actually goes within the appliance on each compute node. Well, what I'm doing here is, again, I'm running the same DMVs to query the data. And what that does for me is it actually brings me back, and it tells me that I have 8 physical tables on each compute node, and they all have a name ending A through H. So I have 40 compute nodes. Each compute node has 8 physical tables, and it lets me know where all that data, or how many tables I have. So now let's start taking a look at creating some of these tables, or querying some of these tables. So I'm going to take a look at a sample database that's about 5 terabytes in size. And one of the things I'm showing here is the ability to use some things like free proc cache that we're used to. So what I've done is I've just cleared the proc cache on all the compute nodes within the appliance, so that as I show these demos, you'll see that they're clean from the beginning. So let's talk about...
Is there anyone in the room that does more than 1.5 billion rows in a table? Okay.
Okay, so we're actually going to join 2 tables here. The second table has 6 billion rows in it, this line item table. And one of the things to notice about this particular query, and I'm going to go ahead and start it off and then start talking about it. What I'm just doing is getting the top 10 order keys by their sum of quantity out of joining those 2 billion row, or 6 billion joining to the 1.5 billion row table. And once I start that off, these two guys are actually what we call incompatible joins. In other words, I have two distributed tables. One of them is distributed on order key, which is my line item table. And then my part table is actually distributed on part key. So what we have to do here is we have to move some data around before we can satisfy that join. And I can go into the admin console and take a look at this query and get a better idea of what's going on. And I don't see the query, so. Oh, it came back already. So this came back in 10 seconds or so, because this is actually a compatible join. My apologies. So this particular query is joining these 6 billion rows to 1.5 billion rows, and it came back in 2 seconds. And that's an aggregation. So not only is it joining those two together, but then it's aggregating the results and finding the top 10. It's very efficient. Let's take a look at this incompatible join that I was just getting ready to show you, and go to the admin console to take a look at it. So I can go in and I can see all the sessions that are running on the appliance from one particular place. And I can see that this is my query I'm running. I can dive into that session. I can dive into the query. And I can see the query that I just kicked off. Now I know it's a fairly expensive query because it's an incompatible join. And I can take a look at the query plan from the PDW standpoint. And what it is this is a sequential query plan. It's got multiple steps that it has to do in row. And I can see which one is currently running, which is the shuffle move. So I'm having to move some data around within the appliance to satisfy the join so that they become compatible so I can join on the join key. If I want to look into this a little more, I can look into the details of the shuffle move. And it brings me back all 320 distributions, and it shows me what's going on in each distribution. And in fact, if I was a little more curious, I can click on one of these guys, and it allows me to delve in and look at the actual SQL query plan that's going on the compute node within the appliance.
So you're doing a clustered index scan on those billions of rows?
On those billions of rows. But remember, it's not billions of rows at a time. It's actually those billions of rows divided by 320. Right. So it's handling hundreds of millions of rows at a time, which is much more manageable from a SQL Server standpoint. If I wanted to look at the performance, I can go over to the performance monitor within the admin console. And what we can see is I have 40 compute nodes all running at about 80% processor. And if I wanted to dive into these guys, what I can see is that each one of these guys has 16 processors. They're all running approximately 80%. This is where the massively parallel processing comes in handy. What we're doing here is, without doing anything other than just doing a create database and a create table and then loading the data, we're utilizing all the hardware within an appliance, which is fairly unusual, because usually when you create a data warehouse, you're going to have some sort of bottleneck somewhere where you're not fully utilizing all your hardware. Here we have 40 compute nodes. We have 16 processors on each one of those compute nodes, and we're using all of those processors across the entire appliance to scan this data very intensely. If I wanted to look at any other performance monitoring information in this appliance, I can simply open up perfmon here, and I can pick and choose which performance counters I want to look at. For example, if I wanted to look at the bytes received going across, I could add an additional performance counter, and I can see all that from the landing zone, what have you. So the performance monitor's nice, and what I can see is now these have all dropped down, which tells me that I'm probably getting pretty close to satisfying my query. It's still going on. It's taken 2 minutes and 50 seconds. So you're like, well, that doesn't seem very impressive, does it? Well, that's because we have an incompatible join. This is really talking about designing your data warehouse on PDW is really important. That design decisions up front are the decisions that you make that really impact performance, because this is what really gives us the secret sauce. For example, if I take the same exact query and what I do is a CTAS, which is called create table as select, I take a complete copy of that line item table, which is 6 billion rows, but I distribute it instead of on order key, like I did before. If I distribute it on part key, I'm now making this query distribution compatible. So what I'm doing here is I now have line item 2 distributed on part key joining to part. This guy just took 3 minutes to run when I had a distribution incompatible join. By making it distribution compatible, I should be able to get a much more performant query. In fact, it's done. So it's 6 billion rows joined to 1.5 billion rows. It took 4 seconds or so, 3 seconds, to be able to find the sum for one of these suppliers.
That's pretty cool.
It's really cool. So being able to do that, now the question is, okay, I picked a distribution key. Did I pick the right one when it comes to distributing my data? So you have a couple things. One, you want to make sure your keys are compatible with other joins you're going to make to other distribution tables. If you're joining to a replicated table, you don't have to worry about that because you have a full replicated table on each compute node. So you're always going to be able to fully satisfy the join in each compute node and be able to bring that data back to the control node. But if you're choosing a distribution key, one of the important choices you have to make is you want to pick a key that is going to evenly distribute that data across the appliance. So the original line item was distributed by order key. And what I'm using here is this dbcc command called show space use, which goes out and it shows me the total number of rows per distribution for that table. And what I can see here is I have a fairly even distribution of about 18.7 million rows per distribution throughout the entire appliance, all 320 distributions. Did I do a good job when I picked a new key just to satisfy that join? And the answer is, yeah, it's fairly good too. It's, again, evenly distributed throughout the appliance. So either one of those from a distribution is a good choice. The question is, what kind of queries are coming to the appliance? Which one of those distributions would be the best to answer the queries that our users are sending us? And at the end of the day, that just comes down to what kind of report query mix do you have. Some additional stuff that you can look at on the appliance is the ability to run DMVs to find out stuff like volume space used. You know, after I've created all these databases, do I have enough space within my appliance? So I don't have to go out and look at each individual LUN in the appliance. I can just run a query that will give me back throughout the entire appliance the free space used for each one of my LUNs. So I know I have plenty of space left in this appliance if I wanted to continue adding databases. So what I'm going to do now is let's talk about, you talked about BI surrounding PDW, right? Mm-hmm. And so we have PDW sitting there, and it's fully integrated with the entire BI stack. So what does it look like when you want to create a reporting services report against PDW? It's no different than what you're used to today. PDW is fully baked into 2008 R2 when it comes to the whole BI stack, when it comes to connectivity. So if I want to create a report against PDW, it's just like creating a report against SQL Server today. If I want to go in and create a new project, I can create a new report server project. And all I need is the IP address of my appliance to create a data source for PDW. So while I'm just opening up reporting servers, I can come in here, and PDW is one of my choices for data source. And then I can come in here and create my data source. The port is always 17,000. And then I can...
I just like working demos.
You were nervous there for a second, weren't you?
I was, like, a test connection was like...
So I'm going to add a new report. I'll go through the wizard just to be lazy. Go to Query Builder. I can do select top 10 star from orders. And it was called orders, right? So just create a tabular report. Let's say I just want to put a few things in my details and finish it up.
Are you a developer? I'm looking into this report design and everything, right? This clearly has no design skills, right?
This, I wanted to just show off the connectivity.
Okay.
So here we can see that, very quickly I can just set up a data source, 2 reporting services, or 3 reporting services, 2 PDW, query PDW, just like you would with any other reporting services report against SQL Server or any other data source. So analysis services, integration services, reporting services, all have PDW connectivity built right into them. It's this easy. So once you've gotten your data onto PDW, using the rest of your BI stack is as easy as it is today.
So you just did a top 10 on how many records?
It's 1.5 billion.
Okay.
And not too bad.
Okay. Question?
So, analysis services is outside. Is there kind of a guideline you would give with respect to when analysis server will become an automated process? Check it out.
So the question is, analysis services is sitting outside of PDW, and what are you going to do in terms of analysis services? The answer there would be is you could build a cube in analysis services on top of PDW. Now, what you do want to care for from a design perspective, and correct me if I'm wrong, Brian, you want to make sure that the analysis services instance that you're going to build that cube on is sitting as close to your PDW appliance as possible, and it's well connected to get that cube data, correct?
Absolutely.
Oh, okay.
I guess where I was heading towards is there might be instances, it seems, that the queries will be resolved much faster here than in analysis services.
That's a really good point. So the question there is, some of my queries are actually going to go much faster on PDW than there are going to be when I build an analysis services cube on top of that. And that answer is correct. The way you would build out the analysis services cube, or you would build out that distributed architecture, is you want to build out a smaller data mart, or you want to create a subset of your PDW infrastructure. And that's what fits in our distributed architecture. I got a slide on that, and I'm going to talk in some details on that one. More questions. Brian, you talked about data load, right? Question there.
Would this make a better case for maybe like rollout style architecture with an analysis services cube, so you can keep your data in place, but yet you've got your analysis services database, which is more just pointers to your data, doing all the data movement?
Brian, can you summarize this?
Yes. So the question is, would rollup be a better choice when you're using PDW? And there's been a lot of people that have asked that question, and we're in the middle of testing that right now. My guess is the answer is going to be rollup is a good place to do this. So the idea is you have analysis services, place your aggregations there. That way, because if you're aggregating data and you have lots of queries that are coming to analysis services based on aggregated data, that could be a very good place to answer those queries very quickly. But instead of bringing all your data in a MOLAP fashion, to be able to answer at the detail level, what we can do is do the hybrid where we have your aggregations at the analysis services level, but if your users need to go to the detail level, then going to the rollup method may be faster. I know that there's some people working on a white paper to answer that question directly for you very soon.
So one of the things that you talked about as well was the load process and how it sets up the distribution and creates all those file groups on each of the appliance. How does that load process specifically work? And one of the things that I get asked a lot is how is that load process impacting my query process with PDW? Because that's going to be important too, right? I mean, you're loading into an enterprise data warehouse, but you're also querying it. What's the process there? I mean, how much is my load process going to impact my query process?
So load processing actually is one of the most compelling reasons to have PDW. And the reason for that is it loads incredibly fast. And I'll get to the part where it impacts your queries, but let's talk about how we load data into PDW and why it's so much faster. So in a normal SQL Server environment, you have to load your data directly into your SMP database, right? And so you have one database, you have to load that data in. The way that we do this here is we actually have, in this particular appliance, for example, 40 compute nodes. We have one landing zone, but we're not going to use that landing zone to actually determine anything about what we're going to do. We're going to use all these 40 compute nodes over on the side to do all our processing. And so when you're loading data, if you have a flat file, for example, sitting on your landing zone, and you have, let's say it's several gigabytes or hundreds of gigabytes large, what we're going to do is we're going to take that data out of that flat file, and we're going to take chunks of it and send it to each compute node, or actually, in particular, each distribution on each compute node at a time. So in this case, we have 320 distributions, right? We're going to take chunks of 10,000 rows at a time to each distribution. And it may not live in that distribution. It may live somewhere else. We don't care. We're just going to round robin through all those distributions and use the data movement service on each compute node to actually chunk through that data to figure out where that data goes. And the reason we're doing that is we're now using not the landing zone to load data. We're using the landing zone to send data to all the compute nodes, and we're using 40 compute nodes at a time to load that data. What we're able to do is really use that massively parallel processing to figure out where that data should go if it's a distributed table, and then send it to that distributed table so that it can be loaded. And to answer your question, which is the next step, we're actually loading temp tables to start with. We're going to create a temporary table to load that data. We're going to load all that data first while your users continue to query the actual real table. The reason we do that is we want to get rid of all fragmentation. So we load the data into a temp table, we sort it in the temp table, and then finally at the end of the load process, once we've taken all those gigabytes of data off the landing zone, send it to the compute nodes, figured out where on the compute nodes that data exists, move it to the temp tables, have all those temp tables loaded, then we do a switch where we bulk load all that data from the compute nodes or from the temp tables to the final destination user table. So during the entire loading process, your users can continue to query the data, and only at the end of the load process do we bulk load that data into the actual user table. And at the end of the day, the reason we do that is we've now bulk loaded that data, already sorted into the user table. That way we have no fragmentation to deal with. And it's
So here we go again. You talk about loading, creating temp tables. Question I asked there, is there something that I need to do in terms of creating those temp tables and such? Because, I mean, I can imagine that will be a lot of workload on my DBA or developer to that perspective.
So no, you don't. There's nothing you have to do. It's all handled for you on the back end. If you let it handle for you on the back end, it all does it within your user table. Now, you do have some choices to create a staging database and to use a staging database to create all those temp tables. But all you're doing is telling it during your bulk load process, which staging database do you want to use? Okay. That's all you need to do. It'll create all the temp tables. It'll load the data. It'll drop those temp tables for you at the end.
Question?
So the package that does data, that takes data from source to loading zone, that still needs to be rewritten.
Yep. So the question is, what happens with the package that I have that needs to get from my data source to actually the landing zone to that perspective? That is something that we still need to create whatsoever. And the answer to that is yes, because your data source might be various data sources, right? I mean, I can think you might have a data source that comes from an Oracle LTP combined with a SQL Server database that you first put into a data cleansing process before you actually put that on the landing zone, and then you're going to bulk load that into. Correct?
Yeah. Or if you're using SSIS, there's simply another destination adapter for PDW that you use. And that destination adapter, you just plug that in, and you can then, instead of going to SQL Server, you're going to the PDW destination adapter. So you should be able to take your SSIS packages, and they would require some modifications. But if you're using SSIS and you don't want to use the flat files, it's fairly minor at the end to just change your destination.
Okay.
So, Dan, do you have a few more things?
Yeah, can I see the load process? Like, is that even visible? Like, I mean, if I see performance degrading on PDW, sure, where can I identify there's a load process going on or whatsoever?
So, again, back to the admin console. I've shown you where you can see appliance state. We've been able to see the queries. We can also see the load process. So we can see query loads in progress, and we can also see loads that have completed. And in this case, I can see all the loads that have happened on this particular appliance over the last few days. I can expand these out to actually see the DW loader commands that they were using. I can see the end time, I can see the duration, so I can now compare. If I wanted to sort by name, I could compare different loads. If I was concerned that I was having a problem with performance, Let's say I've had a load that normally takes a half an hour, and now all of a sudden I'm 45 minutes into it. I can normally dive into this load, and I can see the details. I can see how, again, the command that was used. I can see how long it took to create staging, do the loading process, insert it, and then clean out everything up. So I could come in here, if it was loading, I could come in here and take a look at the progress of it, see how many rows were rejected, how many have been inserted. Possibly, maybe that load progress, I was expecting to be done in half an hour, but I come in here and I see it's actually inserting a lot more rows today for whatever reason. That would give me some comfort to know that there's nothing really wrong, we just have more rows today. If there was things going on, I could go ahead and dive into the session ID, which this one's been done for several days, so I'm not going to be able to see it. But normally, if it was running, I'd be able to dive into session ID, see all the queries, dive into the queries, and then dive into the actual query plan at the SQL Server level, see if there's something kind of funky going on, if it was a little different than what I'm used to.
So another thing I see is the backup restore and the backup integration within the appliance. Could you show that as well?
In this particular appliance, there's not much to show here, but what it would normally show is when backups had been taken on the appliance, how long they took to run, what the duration was, who did it, all that kind of stuff, so that I could know without having to go look at the backup node, without having to dive into the appliance right here in the admin console from an administrative standpoint, did my backup complete and when. And the idea is that backup's been taken, it's now on your backup node. The idea is that you would then take some sort of enterprise backup system connected to that backup node and get that backup off the appliance at some point.
So DBA's word nightmare, right? Locking. What's that locking tab for?
So you want to see all the locking going on in the appliance. You can see that from here. So in this particular case, this appliance is on the West Coast. Nobody's on it right now because it's early for them. But I can see all the locks that I've taken. For example, when I created that TechEd database, so I have one connection that's locked that, but it's just a shared lock. And I can see each one of these locks. If I was concerned about some locking or some blocking going on, I could come in here and see what's going on. I can even dive into a session if I was concerned that somebody was blocking somebody, see what queries he's running. And I can also see at the bottom of this session, I can see the locks that he's been taking. I can then dive into each query if I needed to find out more information. But it's all round robin. You can see the blocks or the locking, you can see the blocking, and you can come down into the sessions and the queries and see exactly what each user is doing, all from one interface.
So would I say that load process is giving me minimal blocking to optimize my query performance?
Absolutely.
Oh, okay.
Absolutely.
On that actually see the entire load. Okay, perfect. So I don't know if you have Power Pivot on your laptop installed. I assume yes, because it's one of the coolest BI products, I think. You have it installed?
Not this laptop because it's fairly new.
So what happens if you install Power Pivot into Excel, you'll see that PDW will show up as a data source, and you could then just go to PDW.
Actually, I do.
Oh, there we go.
You want to see it?
Just the Power Pivot connection, where you could say I could actually connect to a PDW appliance.
So you just open up Power Pivot, and you can go to other data sources. And one of the choices is PDW again.
And from a time perspective, I'm not going to ask you to pull in 1.5 billion rows into Excel Power Pivot, but I assume it's perfectly possible. I just don't want that to transfer.
It is perfectly possible, and I have done it, and it does work.
Okay, perfect. Okay, let's switch back to this. So we looked at the query processing, and we looked at the query execution. We also talked about the replicated distributed table architecture and the ultra shared nothing architecture, where you're actually going to put your tables in such a way that the most frequently queried tables that you're going to use in those joins is split them out, and that's what we call the ultra shared nothing architecture, because you're actually putting that on an individual compute node, and so your query will actually go in your distributed environment, your distributed table with your replicated table will run on that compute node specifically. So the ultra shared nothing architecture allows you to also push data from an SMP from PDW to an SMP environment. We have some guidance. It provides you fault tolerance and such. We also looked at the administrative console for PDW, where, we looked at the query activity, the load, the backup and restore, look at the locking, active sessions. Any alerts on the appliance, I think that's significant as well. You can actually see within the management node whether you have an issue with a memory module or performance has degraded because some memory module has gone bad or whatsoever. So those alerts will come up. We are building a management pack for PDW as well, so you can integrate within SCOM. There's going to be a management pack available that will actually pull all of that information in there to get the appliance status. Brian also talked about the PDW configuration manager, where you can actually shut down an entire appliance for whatever need it might be. But you decide in the future to, on the PDW roadmap, to upgrade the backup device or whatsoever will be one of the key functionalities there. Now, looking at putting this all together, PDW from a central data warehouse perspective fully integrates within this distributed architecture where you could build out your analysis services cube, as was mentioned earlier. That could be a subset of what I have sitting on PDW. You can integrate that within Fast Track Data Warehouse to actually bring that enterprise data closer to the user if you have geographical distributions or whatsoever. The technology that we use there is a parallel database copy technology that allows you to do rapid and consistent data movement from PDW to your actual smaller data marts that you might create out of this. Now, one of the key reasons you might want to do that is to meet different service level agreements in terms of performance, capacity, loading, concurrency, or actually bring that data closer to your users. So you have a lot of flexibility within that distributed architecture, but you'll see that PDW as your central data warehouse is probably going to be one of your best solutions with direct reporting going directly to the appliance rather than offloading that to an analysis services cube or whatsoever. Now, if you look in detail on this distributed data warehouse architecture, we have a third-party data integration where you could use SSIS to put data onto the landing zone, from the landing zone load it into PDW. We could just go and grab data files from existing systems, load those onto the landing zone and then into PDW as well. In a typical distributed architecture, you could have like regional reporting where a fast track reference architecture might satisfy the need. So what you're going to use is that parallel database copy, the copy from PDW into fast track, and then you're going to use your BI tools on top of that. Looking into the roadmap, SQL Server Denali, Project Crescent, that you definitely saw some demos around it, will be sitting on top of that. Will be sitting on top of PDW, or will be sitting on top of your data mart in a distributed architecture. Familiar with the SQL Server query tools, high performance reporting you can do on an analysis services cube. So we do have the full stack in terms of PDW data warehousing offerings. Now, what's the right solution? Is it a fast track? Is it a PDW? The key difference there, it needs to be clear and as a takeaway from this session, is PDW is massive parallel processing. I think we showed that looking at all these compute nodes. Fast track is an SMP architecture. What's going to be important in your key decision level is not going to be storage, but it's going to be the number of concurrent users. It's going to be the query complexity. One of the key things that Brian identified there was the load process as well. Okay? If you have large amounts of data loads with consistent query processing, what you probably want to look for is look for PDW rather than looking for fast track architecture. And key is, what are you as a customer or a partner looking for in a solution? Are you looking for the simplicity of an appliance, or are you going to build out the fast track reference architecture? Knowing that the fast track reference architecture, and I do want to emphasize that the entire fast track reference architecture with disk optimization, storage optimization is a single out-of-box solution into that PDW appliance, which is single box up in couple of hours. You just spin it up, you start loading your data, and you have the wizards and the tools integrated with that. One of the things that you need to see as part of this presentation as well is that everything that we do is on economically affordable hardware. We're not using anything different than commodity hardware. I mean, we're using HP ProLiant servers. We got reference architecture with different hardware vendors to align to the storage needs or storage capacity that you already have in place. Even if you go back to that initial slide where I said SQL Server Enterprise might be a good solution or a current solution you have in place, you could still optimize that by using some of the best practices that we have available from that fast-track reference architecture, or any guidance that we have from our SQL Server CAT team, customer advisory team, on their SQL CAT portal as well. So PDW, interop with any of the leading BI products. Very robust, very proven technology. As Brian showed you, was clustering is in place. Very, very well proven technology on Windows Server 2008 R2. We have the high availability built in, massive parallel processing, the distributed query optimization in combination with that replicated table architecture provides us with a very different and very unique ultra-shared nothing architecture. That's going to be the key differentiator if you compare PDW to any of our competitive products in that area. We have third-party integration, MicroStrategy, Business Objects, Informatica, fit into the master data management and data quality services with PDW as well. Now, there's definitely some sessions where looking into roadmap, new features, column store, for example, being one of the features in the vNext of PDW. There's a session that was presented yesterday on column store. I put it in the slide deck for reference purposes. You got the session code. If you later on want to review the recording, you can do that as well. Now, what if you want to deep dive into what we have available as a reference architecture, appliance architecture, not only from a data warehouse perspective, but also from OLTP, consolidation and such. There's a session that's going to be presented, I think, tomorrow. It's the Microsoft SQL Server Reference Architecture and Appliances session. And we do have some deep dives and customer evidence as well. The upsizing and modernizing Microsoft BI Stack and Fast-Track Data Warehouse is presented together with a partner that deployed the Fast-Track solution. And then we also have what's new, what's the best features in Fast-Track Data Warehouse 3.0 as well. If you have any more questions, you want additional demos or whatsoever, feel free to come to the DBI product booths in the expo hall. There's going to be lots of folks around there that could help you with the BI, could help you with the data warehousing and so on. If you need guidance on certification, like I know we're both certified masters, we get a lot of questions on how does that certification work, what's the key value to it. You could also go to the Microsoft Learning booth. If you need to find any of us later, find me in some of the sessions. I'm the track program manager for database, which means I technically jump by every session to make sure I kind of get a grasp of what the session is going on or what my presenter is doing. We got a couple of minutes left. Any more questions? We'll gladly answer those. Other than that, yeah, you're probably going to be looking at the next CDP release. You could follow at SQL Server Twitter account to updates. Try some of our bare metal hands-on labs, or come to the demo stations. Typical TechEd resources.